In psychology, thinking and language. Essential question can't get any more simple than that. What is thinking? So, what we're going to look at is how thinking and language affect our psychology. Thinking is, well, let's look at units of thought as to what thinking is. It's mental activity involved in the understanding, processing, and communicating of information. So that is one example of what thinking is all about. Under that mental activity, we have symbols. Symbols are objects that stand for something else. So symbols would be a unit of thought. We have concepts. Concepts are groupings of objects, events, or ideas that have similar characteristics. So here is when we take some belief or idea that we have and we group things to have a concept. Example, let's say you have the concept of religion. You're going to group everything that you know about religion in there, about your faith, about your church, about your youth group, etc. Prototypes. A prototype is an example of a concept that best exemplifies that concept. Prototypes are important because you cannot always get every detail, and this is a hard concept, I know, for students to understand, but you can't always get every detail about a topic and say this is the way it is. There are always exceptions, and every detail on every person is different. So a prototype is an example. For example, when I show you how to do a project and I have an example to show you, yours is going to be different, but it's going to be similar. Problem solving. People do not go from problem to solution in one giant leap. There are steps to get from problem to solution. And we use algorithms. An algorithm is a specific procedure that, when used properly and in the right circumstances, will always lead to the solution of a problem. Sounds a lot like math, doesn't it? And algorithms are used in math, but they're also used in everything that you do. You just have probably not heard of them called that. But any procedure that you have to solve a problem is an algorithm. Another word for an algorithm would be a formula or a method of doing something. Okay, in math, again, math and science, you got formulas. But in everyday life, we have just, a method of doing something. Problem solving 2. This is an example of a project actually that a student of mine did. And you can see this person really liked art, of course. But heuristics are rules of thumb that often help us find the solution. Rules of thumb, it's an old word from the past. And it just means that, you've got a few rules that you solve in, or that you have in solving a problem. Okay, and again, heuristics, they are rules of thumb. Now, what that means is it's not always the case. So you follow these rules of thumb, but you sometimes don't get the right answer. Heuristics are shortcuts. Okay, and you guys all do this in math, I know. You got this long, drawn-out way of doing a math problem, and your teacher wants you to write down all the steps and all that, but you can solve it quicker, so you use a shortcut. Let's look at problem-solving methods. One method is trial and error, and it's not a very good method. We do have keys that help us. The key to getting the answer is this. But trial and error just simply means you keep trying things until something works. And so that can be very time consuming. Difference reduction is a heuristic. So with difference reduction, you have a way to do something. You try it, it doesn't work. Okay, then the next time you change a variable. That's difference reduction. And one of the things that you do here is you identify a goal. Okay, I want to put in a new motor in my 57 Chevy. So we look at where are we in relation to that goal. Okay, well, we have the old motor pulled out. We got the body of the 57 Chevy. We have a new motor. Okay, we got a long ways to go. Where are we in relation to that goal? What direction must we move in order to get closer to it? Okay, our goal is to get that motor in that 57 Chevy and make it drive. So what direction do we have to go? Well, I guess the first thing is put the motor in, right? So we need to set that motor in and then start to attach all of the things we need to attach. So there are problem solving methods. The picture, if you're wondering, is how do you make scrambled eggs? And if you took an alien who knows nothing about eggs and you just said, here's the eggs, we want scrambled eggs, you might get something like what you see on the left there. But if we do our heuristics, we'll figure out that we first must crack the eggs and pour them in a bowl, and then add whatever, a little milk or cheese or whatever, and mix them and stir them and break up the yolk and all that kind of thing. And then we have to put them in a frying pan, and then we have to cook them, and we don't want to burn them. So we get, those are examples of the heuristics. It's all just common sense to us because we've done it, but we actually do have steps that we use. Problem solving again. Number 3 is means ends analysis. So we look at the means to the ends. Okay. Go back to the math problem. We know that we follow every step we're going to get there. Okay. Means ends analysis. All right. Do I need to go through all of those? It'll take a lot of time. Or if I know a shortcut, can I just use the shortcut? Sometimes it's okay to use the shortcut. But means ends analysis. If this means I use the shortcut, I don't write down all my steps, my math teacher is going to take a whole bunch of points off because I haven't shown my work. So that's why we have to analyze. Certain things we do will have certain results. Example, cooking. Let us go back to the eggs. If we don't cook them the right way, you won't get your good scrambled eggs. Sometimes you can work backward. This is the way some people do it, especially guys that like to tinker on motors and motorcycles and cars and all that stuff. Sometimes you work backward. So you want to figure out how to put something in. You start with a whole and you take it apart. And that's working backward. And we also are breaking down a problem into parts, then dealing with each part individually. Okay. So we know we heard a sound in that motor. We have a guess as to what it might be. So we're going to try individually to take care of that. And we start by examining the final goal and then working backward to the present position. So that is what working backward is. And sometimes that is the way to do it, especially if you don't know the solution to something, but you know what it should look like. Working backward can be a good way to do it. Analogies. Analogies are similarities between two events. And like I was talking to you earlier, we don't always like to lump things together because sometimes we say, hey, well, those two aren't alike. They have these differences, but you have to look at, are they more similar or are they more different? And it's a way of higher level thinking too. Sometimes you can take two completely opposite things and say, what are the similarities between them? I actually used to like to do that when I was teaching American history. Example, you get a study book for ACT, so then you should get a study book for the GRE. ACT test you'll all be taking probably as juniors, and the study books do help, but again, it's more time and effort. And my example here is the GRE graduate records exam. I've taken both the ACT and the graduate records exam, and the graduate records exam is to get your master's degree. It is the hardest test I've ever taken. When I got done with that test, I felt like I didn't know anything. I put it bluntly, I felt stupid. Give you an example. The vocabulary part of the GRE. I was supposed to start with the easier words and get to the tougher words. So the further you got into the test, of course, you had a time limit. further you got into the test, the words got tougher. I got stumped on number 5. So I knew, oh, holy cow. These are real tough words. Now, where am I going with that? The analogy. I did okay on the ACT test. I didn't get a book, so I didn't get a book for the GRE. And if I ever have to do that again, well, I won't now at this point in my career, but if I ever would have had to do the GRE again to try to get a better score, I would get the book. So similarity between two events. Okay, standardized test for college. I don't need a book because I did okay on the ACT without a book. But I really did need a book for the GRE. So example, I hope you can see that example. Sorry for the long story. Insight and incubation effect. Okay, insight is like inside knowledge that you have. And the incubation effect is just like the chicken there. Sometimes you just need to sit on it a while and think. Insight, the answer just comes to you all of a sudden after pondering for a while. You think about it for just a short time and boom, you got the answer. Incubation, you take a break, you come back, and then the answer hits you in a flash. But you sit on the eggs for a while. You take a break. You come back, and boom. And we've all had probably both of those things. I've had both of those things definitely happen. There are obstacles to problem solving. Okay, like putting together a puzzle, like the puzzle piece missing. A lot of it has to do with your mental set, the approach used before to solve a problem. Many times the mental set is, I did this to solve this problem before. I should be able to do this to help solve this problem, which is similar. But problem with the mental set is it doesn't let us look outside the box. If this worked to solve this problem before, and this doesn't work to solve this problem now, I am in trouble. But maybe I have to look outside the box. I have to look at something else. So the mental set can be it's a help in that you get the heuristics, but it's a barrier in that you don't look beyond. Then we have something called functional fixedness. I've always liked terms like this that are kind of tongue twisters. Functional fixedness. It's a tendency to think of an object as being useful only for that function that the object is usually used for. Give you an example. My tongue's not working so good today. You have hammer and nails. So you take the hammer, and we know what to do with that. You take the nail, you pound the nail into wood or plaster, whatever it might be, okay? But seeing the hammer doesn't mean it can just be used for nails. We tend to think of it just in that way. Or if you get the nail might be the better example. You get a nail, we just think of a nail that goes into a piece of wood to make two pieces of wood stay together. But a nail could be used, to poke holes in something. It can be used to, maybe open a door or something. You take the nail into the lock and, use it like that to pick a lock. Anything that you could use something long and thin for. But we think of nails as only used for pounding into wood. All right, problem solving and creativity. Okay, creativity is so useful in problem solving. And I know what you're thinking. I'm not very creative, which is probably why I don't solve problems very well. Well, creativity, not everybody is as creative as everybody else, definitely. But creativity can be very helpful in solving a problem. And you might be creative in one area that I'm not. And I might be creative in an area that you're not. So that's the other thing to realize. Creativity isn't a general term for all kinds of creativity. It is in areas. Convergent thinking. The problem with convergent thinking, converge, you come from somewhere and you kind of surround something and you finally figure it out. That thought is limited to available facts. Divergent thinking, one associates more freely to the various elements of a problem. You can be more creative if you use divergent thinking. So one convergent is do this, and eventually you'll get here. Divergent thinking is, well, maybe if I tried that. Or has anybody tried it this way? That's divergent. There are ABCs of problem solving. And I'll get to my Rubik's Cube there. I don't know if I ever told you a story about the Rubik's Cube or not in high school. But number one, A, assess the problem. So what is the problem? We need to make the Rubik's Cube look like that. Number two, brainstorm approaches to the problem. Okay, how can we do that? If you get a Rubik's Cube that's all mixed up, what would be possible ways to try to make it look like that? Then choose the approach that seems most likely to work. So you use some logic here. And then you do it. You try the most likely approach. Now remember I said trial and error. That's what you kind of do with a Rubik's Cube. It's not the best way to do it. It'd be much better if you had an approach. And then you evaluate the results. E, what worked and what didn't. Now, where am I going with this? Okay, my story on a Rubik's Cube, it frustrated the heck out of me in high school. Everybody had Rubik's Cubes, and I could never, and I've never made a Rubik's Cube look like that once it's all mixed up. Of course, obviously, people mix it up, and then you try to make it look like it's supposed to. Never was able to do that. I would get it so like one square on each side didn't fit, and that should have been easy to solve. I got to that point, I think, where I had one square on each side that didn't fit, and that should have been just a few turns, but no. And then there was my high school friend, we'll just call him Joey Genius over here. And Joey Genius took that Rubik's Cube with my one on each side not working. He did a couple of twists, boom, 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 and he got it done. And then he was known as the guy that could always get the Rubik's Cube, and people would take it and mix it as many ways as they could and give it to him. And usually 5, 6, 7 turns, and he had everything done, and he did it so fast. There were probably more than 6 or 7 turns, but he did everything so fast. He had a heuristic. He had an approach. He knew what to do. He knew which ones to turn and how to twist it. Reasoning and use of information to reach conclusions. Deductive reasoning, the conclusion is true if the premises are true. So if A is blue and B is red, and you put them together, you get purple. Inductive reasoning is from individual cases or particular facts to reach a general conclusion. So here it's not as simple. You look at, you take individual cases and facts and you put them together and you get a general conclusion. It's not always the conclusion you're looking for, but it's a general conclusion. Where deductive reasoning is, no, this is the answer. Inductive reasoning isn't always that way. Reasoning 2, inductive reasoning. It's impossible to prove these true because, like I said, you're getting a general answer. We can prove them false, though. That's pretty simple. If you have one part of it that's false, it's false. And then we have confirmation bias, which exists. Confirmation bias is people seek to prove their hypothesis rather than disprove it. We tend to, this is our hypothesis, we want it to be true. So we use a little bias and we try to get people to see it our way, or we tweak the facts a little bit. A lot of people do this, okay? Decision making and judgment. We weigh the pluses and minuses. So for decision making and then judging, we look at if this happens and this happens, here's what we have. A great way to solve problems, and I encourage all of you to do this, I do this, is take a sheet of paper out, weigh the pluses and minuses. Write on one side. These are the, one column, these are all the good things about my decision. These are the bad things about my decision. See which side has more. Shortcuts in decision making, you can use them, but sometimes you miss important points. Representativeness heuristic. That's a mouthful. This is the tendency to go what we think it will be like. And we do this all the time. Well, I think this is the way it'll work. Or this is, I think, what it should look like. Okay. And that's okay, except that many times then you might miss a major point or you might miss some detail that makes it work. In cooking, you don't want to miss any ingredients. During the pandemic here, I've done all the cooking at our house. Tried to do a lot of different things, recipes and stuff. And I have learned very well that just because I think maybe I don't want to put this ingredient in, that doesn't always make it come out the way you want or taste the way it should. Availability heuristic, what we know to be true based on experience. So this is a barrier because, well, we know this about, this is part of like what causes racism and stuff, is we know this about people because I've seen this. I've seen this behavior of these people that look like this. And the availability heuristic is we know this is true based on experience, but the problem with the availability heuristic is we're not looking outside the box and we're looking only at our knowledge, not the knowledge of everybody else in Minnesota or the city or the county or the world for that matter. We do have anchoring heuristics. Now, these are very important, especially for you in your faith, and with most of you being Catholics, you're going to have an anchoring heuristic in the Catholic faith. And it's based on certain standards or ideals you hold. These are important. These are what makes you make good decisions versus bad decisions many times. Is you might say, well, I know this is the way Catholics handle this. Then we go to decision making 2. Here we have the framing effect. The way you word things affects decision making. Really find this in surveys and things like that. The way you word things affects your decision making. The way I word things when I explain things to you frames them. We have overconfidence. We tend to have a great deal of confidence in our decisions, right or wrong. We usually think we're right. I ask you why. Page 194 has got a good discussion of this. But, we did it. We figured it out. We don't like to be proven wrong. I mean, that's probably a human characteristic, right? We might say, I followed all the rules. I did this. My mom and dad did this. This is the answer. Let's get into language. Okay, so all of that has to do with decision making. Now, language. Language is the communication of ideas through symbols that are arranged according to rules of grammar. And by the way, your title is language off on the left-hand side there. So we have basic elements of language. Phonemes, these are basic sounds, letters, combinations. We know that M-O sounds like mo, right? We know that TH sounds like th, okay, the th sound. Morphemes are units of meaning using phonemes. So now we put these together to make words. We know the word word, W-O-R-D-S, because we kind of sound it out. We've seen it before. And this is how we do compound words and 2-syllable words. And like meaning, if you look at in number 2, they're units of meaning. We know the word mean. We know ing means the act of, and so meaning, we get it. And then there's syntax. Syntax is the way in which words are arranged to make phrases and sentences. So we, in the English language, American English, we arrange our words in certain ways to make phrases and sentences. One way to tell people that are learning English or people from another country that don't know English well is they often put words together in different ways, and the sentences sound funny because they don't word things the way we do. Syntax is the developed way to arrange things in a sentence, okay? Verbs and nouns and adverbs and all that kind of stuff, as well as complete sentences. Language 2, look at that cute little face. Semantics is the meaning of language, the way words are used. It is more than one meaning. English language is the toughest language to learn in the world because we have so many meanings to words. But semantics, again, is the way a word is used, okay? If we say, hey, look at that awesome bank shot, we know that we're talking about basketball. Versus if we say, I'm going to the bank, we know that that's a place. It's where we have our money. Stages of language development. There are stages. This goes along with Freud's theories of development. First stage is crying, cooing, babbling. My little grandson KJ is in that stage. They start to learn words by 18 months. Children usually have about 25-word vocabulary. And of course, every mom and dad wants the baby to say mom or dad first. Number 3, development of grammar. Now here you learn from others the way to talk, the way you put things together, good English, etc. So again, if you're brought up with people that don't have good grammar, you learn bad grammar instead of good English. And how do we learn language? There's hereditary influences. These are called learning acquisition devices, or LAD. Animals don't have this, but we have hereditary influences based on your culture. Language, religion, all of those things. We've talked about that collective unconscious idea. Archetypes, well, some of those terms that we've used in Psych. From 18 months to puberty, we are most capable of learning language. And this is why I say this every year to students. We do things so wrong in the United States when we teach foreign language. You don't start foreign language in 9th grade if you really want to learn it. You're still in puberty, but you're at the end of puberty, or, middle of puberty. But where you want to start is in preschool, elementary. There are immersion schools that start teaching foreign language, in kindergarten. If you started learning in kindergarten, you would have language by the time you were an adult. And I can give you a great example. I have 2 nieces and nephews that parents were in the army in Germany. They grew up in Germany. They lived on an army base. They had a nanny and stuff that spoke German. And those kids grew up bilingual. They learned German. They moved when they were in their teens, mid-teens, but by that time they had learned to, speak German pretty well. 1 and 2-year-olds learn foreign language with ease. Like I said, just like they learn any other language, you teach them in a foreign language, they're going to learn it that way. The environmental influences, observation and imitation, those are important. You observe, you imitate. This is kind of what we do in high school. Spanish here at BA and other schools is observe, imitate. You learn the words and then you try to imitate the way they are spoken when you hear them on a tape or a video or something. So again, bilingualism, easier when you're young. You start learning 2 languages when you're, 2, 3, 4 years old. It's no big deal. You try to learn another language now, it's a problem. Okay? It's hard. 40 million Americans, and this is an old number too. It's way past that. This would be the number that's in your textbook. And your textbook is maybe almost 10 years old now, I think. But English is their second language. And 40 million Americans speak something else other than English, and then they're learning English. Would you please then do your summary and just look at, what is language and what is how we think. Think of the heuristics, think of how we put together things, and then think of how we learn language.